In this video, we will be looking at 2.1, solving quadratics by factoring. So we've done all this factoring leading up to this point, and now it's time to actually solve equations that are made up of quadratics. So my essential question is, how do I solve a quadratic? So to solve something, so the one thing we haven't seen is any kind of equal signs. We've just been kind of simplifying, whether that be if the instructions were to simplify, so we're distributing and combining like terms, or if we're factoring, so we're kind of pulling things apart using division. Now to solve them, we have to use one of the more powerful numbers in our whole spectrum of numbers, and that's going to be that number 0. So first thing I want to talk about is the 0 property. Very strong property used in multiple disciplines in mathematics, and it's just like the idea of what can 0 do, especially when we're talking about multiplying. In essence, what it's just getting at is 0 times anything equals 0. So for example, I can say 0 times x plus 2, and that will equal 0. Or I could say x minus 3 times 0, and guess what that's going to equal? 0. So now let's talk about using the 0 property. So we are using the 0 property to solve. I'm going to use my two ideas from above. I'm going to say, let's say I had x minus 3 times x plus 2, and that was already equal to 0. I need to figure out x values to make this a true statement. Well, the idea is, if I can make x minus 3 or x plus 2 equals 0, if I can make either one of these equal 0, so if I can make x minus 3 equal 0, then this whole left-hand side will equal 0, because I'll have 0 times something. Then the entire left side equals 0. So if I can make this equal 0, 0 times x plus 2 would equal 0. If I can make x plus 2 equals 0, then I have x minus 3 times 0 equals 0. So that's going to be our goal. So to do that, I will set each piece equal to 0. So I can say x minus 3 equals 0, or x plus 2 equals 0. Now I'm just solving some pretty straightforward, relatively easy one-step equations. Add 3 to both sides on this one, and I get x equals 3. Over here, I can subtract 2 from both sides, and I get x equals negative 2. Now, for the sake of checking our argument, let's plug these answers back in and see if it actually worked out. So I'm going to rewrite our equation we're working with. I have x minus 3 times x plus 2 equals 0. So on this side, I'll plug in my 3, and then on this side, I'll plug in my negative 2. So we're going to plug in 3. So I have, this is my x equals 3 side. So I'm going to have 3, just changing the x into 3, minus 3 times 3 plus 2 equals 0. Well, 3 minus 3, there's my 0, times 5 equals 0. And 0 times 5 is 0, and we get 0 equals 0. So it worked. So we can see that 3, by doing this solving, by setting this chunk by itself equal to 0, solving, I get a value that makes it a true statement. And that's what we're after. We're just looking for those x values that make it a true statement. Let's look at our negative 2. So say I have x equals negative 2. I'm going to plug that into my equation, and let's see how it unfolds. So I have negative 2 minus 3 times negative 2 plus 2, and does that equal 0? Let's do our math. Negative 2 minus 3 is negative 5, and when I do my negative 2 plus 2, there's my 0 equals 0. So now we multiply together. Well, we know negative 5 times 0 is going to equal 0, and we get 0 equals 0. So if we can get two things to multiply together and it equals 0, then we can set each piece equal to 0 and solve individually. So now what we have, so what we found is x equals 3 or negative 2, and we'll write it as x equals 3 comma negative 2. So you don't have to write the word or. Okay, so now this form right here should look very familiar. We've done this a lot. We've started off with our quadratic equations, and then by factoring, we've gotten into this form. So that's what we're going to be doing. We're going to be given quadratics, and then we factor, and then we solve. Now, something that's really important before we even think about factoring is, going red on this, is we always, always, always make sure your equation equals 0 before factoring. So we have to make sure our equation is equal to 0 before we can factor. Now, the words I will be using is set equal to 0. So I'm going to use that as my first step. So the equation I'm going to be looking at is x squared plus 16x equals 64. So what we're really finding is what x makes this true. I can plug in an x, and then when I simplify, I'll get 64. So our first step is to make sure it equals 0. So step 1, set equal to 0. And this, I'm writing this in this form because this is what I'm going to be saying. This is how we're going to be saying it in class. Okay, is it set equal to 0? And what that looks like is, as I have my equation, I need to make this equal 0, so I will just subtract 64 from both sides. There are no like terms to combine, so I get x squared plus 16x minus 64 equals 0. So now we need to do, now we're on to our second step, and that is factor. So we can use our AC method to factor. Here's my side work. So I have 1 times negative 64, so that's my negative 64. And then I have my 16, my b term in the bottom, and we're wondering what multiplies to negative 64 and adds to 16. Well, if I do oh, I made a small mistake to begin with. Let's make this equals negative 64. So that's equaling negative 64. Those become plus 64s, and that's a plus 64. Sorry about that. So I just changed that to a negative 64 right there, which makes this a negative 64 right here. And then I need to add 64 to both sides. And now I have x squared plus 16x plus 64 equals 0. So I'm adding 64 to both sides. So I have x squared plus 16x plus 64 equals 0. A times c is positive 64. Then I have my positive 16 down below. So then I can say negative 8 and negative 8. Positive 8 and positive 8. And I have x squared plus 8x plus 8x plus 64 equals 0. Now we're just factoring by grouping. And I get x times x plus 8 plus 8 times x plus 8. So we'll bring our x plus 8s together. Then I bring my x plus 8 down, and we get that equal to 0. So we factored it. Now our last step is to use the 0 property. So I can say x plus 8 equals 0, and I can say x plus 8 equals 0. We'll subtract 8 from both sides on this one, and we get x equals negative 8. Subtract 8 from this one, and we get x equals negative 8. I got the same x's, so for this particular problem, there's only one solution. So we'll just say x equals negative 8. Okay, let's do a couple more examples. The first one I'm going to do is if, say, we just have a greatest common factor. So this is kind of like the easiest one, but since it's not our AC method, we tend to make it more difficult. So let's say I had this problem right here. So number one, if I had 4x squared plus 2x equals 0. In this case, am I already set equal to 0? I have everything, all my x's and stuff on this side, and on my right-hand side I have a 0. So I'm ready to move on to factoring. So I want to find the greatest common factor. So what can I factor out of both 4x squared and 2x? I can factor a 2x out. I get 2x plus 1. And I'm done factoring. Now I can use my 0 property where I take each piece and set it equal to 0. So I can say 2x equals 0. And I can say 2x plus 1 equals 0. Now we're just solving for x. So on this side, I'll divide by 2, and I get x equals 0. And on this side, we'll subtract 1. So 2x equals negative 1. Divide by 2, and we get x equals negative 1 half. So I can say x equals 0 comma negative 1 half. And that's how we can solve when it's just a greatest common factor. On my second example, I'm going to use the AC method. So let's say we have 6y squared plus 20 equals 23y. Well, is this set equal to 0 yet? It is not. So I need to subtract 23y from both sides. And now I have no like terms to combine, so I'm just going to have 6y squared minus 23y plus 20. I'm writing it in standard form, equals 0. Now I'm in set equal to 0, and we're ready to factor. So I'm going to use my AC method, do my side work over here to the side. 6 times 20 is 120. And then we have negative 23 in the middle. We're looking for two numbers that can multiply to 120 and add to negative 23. So I'm going to use negative 8 and negative 15. 8 times 15 is 120. And then negative 23, negative 8 plus negative 15 is negative 23. So now we'll use these two terms to split our b term. So we have 6y squared minus 8y minus 15y plus 20 equals 0. I will factor by grouping. The common factor in 6y squared and negative 8y is 2y. And I'm left with 3y minus 4. The common factor in negative 15y and positive 20 is a negative 5. And I'm left with 3y minus 4. And that equals 0. We can bring our 2y minus 5 down. 2y minus 5, and then we'll bring our 3y minus 4 down. And that equals 0. Now we can set each piece equal to 0. I have to go over here to do that, so I have enough room. So I have 2y minus 5 equals 0, or 3y minus 4 equals 0. So we'll add 5 to both sides. So 2y equals 5. Divide by 2, and we get y equals 5 halves. Over here, we'll add 4 to both sides. So I have 3y equals 4. Divide by 3, and we get y equals 4 thirds. So our answer would be y equals 5 halves, comma, 4 thirds. So just to recap, first we set it equal to 0 by subtracting or adding whichever we have to do, everything from one side of the equation to the other. Then we factored using our AC method, turned it into a factor by grouping. We get our factored form of our quadratic. Then we take each piece and set that equal to 0. 2y minus 5 equals 0. 3y minus 4 equals 0. And then I'm just solving some relatively simple. I mean, and when I say relative, what I mean is, we're all different. So, but in comparison to other equations, these are pretty straightforward. Some two-step equations. So we just solve each two-step equation, and then we get our two answers. And that is how we are going to use factoring to help us solve these quadratic equations. So I want to thank you for watching this video, and I hope you have a great rest of your day.